Monsoon rainfall is very important in India because most of the rainfall falls within the monsoon season, and that water has to be preserved till the next season. So we all look forward to the onset of the monsoon and the rainfall with great expectation. So it's very important to forecast this rainfall accurately. And the various forecasting timescales are the short term, which is up to 3 days, the medium term, which is up to 7 days, extended range, which is up to 15 days, and long range, which is beyond 30 days. The other forecast is for seasonal average, which is the most difficult rainfall to predict. The seasonal forecasting can be done either using the past data of the previous months, and this is called statistical method, or you can use coupled ocean atmospheric models to predict the seasonal mean rainfall. The method which uses models involves what is known as the general circulation models. These models uh, divide the entire globe into small cubes, and there are millions of these cubes, and each cube we incorporate all known laws of physics, conservation of mass, momentum, and so on. And then, of course, we use the number crunching part of the computers to march in time. Now, here is an example of a forecast made with such models based on the initial condition on 19 July 2015. And in this figure, the green is the forecast for all India monsoon rainfall, blue is the actual observation, and black is climatology, that is what would be on an average. And you can see that the forecast was quite good uh, for 1 week, except for the 23rd of July, when the forecast was about 2 millimeters per day lower than observation. Of course, on the last day, the error is somewhat larger. So beyond 1 week, the error starts increasing because of some modeling issues in the model. Now, here is the same figure shown in terms of correlation. So look at the first 5 days, so-called pentad 1. The correlation between observation and the model forecast is almost 0.8, which means quite good. Then when you go to second pentad, it goes down to around zero point 0.6. The third pentad it goes down to around zero point 0.4, and the last pentad is as low as zero point 0.2. And here I have shown results from different versions of a model used by the India Met Department. Now, on the right hand side is shown the error, root mean square error, and you can see that it starts at around 30% and goes on increasing to around 60% by the fourth pentad, which means the forecast beyond 2 to 3 weeks is not that useful because of the high error. Now, the other important use of these models is to do cyclone track forecasting. It's very important for saving lives and making preparations for the onset of the cyclone. And so here is shown in red the prediction of the India Met Department, sum of many models, so-called multi-model ensemble, and black is the observation. And you can see that the track forecast is quite good for a period of 10 days shown here. And if you now look at all the forecasts made in the last 10 years, you see here that the error in the track is approximately now 97 kilometers. So it's better than what it was 10 years ago. And the error in where the place where the cyclone comes on land is called the landfall error, and that is gone down from around 100 kilometers to almost 50 kilometers. So cyclone track forecasting is getting better and better, and it's saving lives and human beings. Now, let's come to seasonal forecasting. Seasonal forecasting can be done by two methods. Uh, One is using the models which we just discussed, and the second is statistical model that use past data of sea surface temperature, surface pressure, winds, and correlate that to the rainfall in the coming season. Now, in the past, before the advent of supercomputers, uh, India Met Department used statistical models, and they were not that accurate. And here is an example for the period 2000 to 2017, comparing the actual rainfall departure from normal with the India Met Department forecast. And you can see that the statistical model, which is in red, is not really able to capture the extreme events like the droughts of 2002 and 2008 and so on, is not able to capture well. Now, this is a problem with any statistical model because they fit the past data to the future rainfall. They are good at the mean, so they get a number close to average, which is 100% here. They do not predict correctly the extreme events. Now, kick up to dynamical models. The expectation was that once the supercomputers came, uh, it was felt that by using laws of physics to predict monsoon, we can do better than statistical models. Okay, and so a lot of effort and time has been spent on it. And here I'm comparing the accuracy of prediction by statistical models and dynamic models, both done by the India Met Department. And you see here that starting from 2011, you can see in 2011 the dynamical model, statistical model made different predictions, and the observation was closer to the dynamical model. You come to 2015, you can see that both statistical and dynamical model predicted a drought, and it came out right. This is observation. But the next year, both the statistical and dynamical model predicted above normal rainfall, but the actual observation showed below a normal rainfall. And same thing happened in 2019. The statistical dynamic model predicted below normal, actual rainfall was much higher. So you can see that the success is not perfect. There are some years both models do well, and some years they don't do well. So there is still need for further research to improve these models. Now, the reason why the models don't always do well is that the monsoon rainfall, this is the All India monsoon rainfall for the year 2009, it goes through what are known as active and break cycle. There is a period about 15 days to longer, which rainfall is above normal. Then it gets into a period where the rainfall is well below normal called the break. And in this case, it lasts almost for 15 days. Then it revives and becomes active, and then there's slight weakening, and then it is active for a longer period. Finally, it gets to do another break, which is equivalent to here an early withdrawal of the monsoon. So here was a year where there was a late onset of the monsoon and one major break and early withdrawal, which made the seasonal mean rainfall below normal. Now, predicting this active break cycle well in advance is not easy. As you saw, the model forecast is good for a week or 15 days, but beyond that, the model starts having errors. And so, to predict rainfall correctly over the entire period is still a challenge. And but the models are improving continuously, and we expect that in a few years' time, the model forecast of the mean rainfall will get better and better. Thank you.